Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. What we will do for our lesson today is we're going to correct the activities, the revision activities that you were supposed to have completed for your homework, and then we'll move on to the introduction of the next subtopic in our book, Climate, and that is looking at part 2, the atmosphere. But before we move on to the work on atmosphere, or the introduction to the work on the atmosphere, I'd like us to correct the last lot of exercises or activities you were asked to complete for your homework. Okay, the instruction was basically you had 12 statements, and from those 12 statements, all you had to do was write down true or false to each of those 12 statements that were given. We'll start from the back and we'll work our way up to the front. I'd like you to read out the statement and also to give out the answer, whether that statement is true or whether it is false. So we'll start from Bill and we'll go across that way, then to the front. Okay, you're expected to read out the statement as well as to give the answer to that particular statement.
The Earth's northern hemisphere is tilted towards the sun in January and away from the sun in July. False.
We all happy with the answer being false? Okay, good. And that's also the correct answer. Number 2, statement 2.
The Earth's southern hemisphere is tilted towards the sun in July and away from the sun in January. False.
We're happy with false being the answer for that statement? Yes. The Earth's southern hemisphere is tilted towards the sun in July and away from the sun in January. The answer should be false. The Earth's southern hemisphere is tilted towards the sun in July. If it was tilted towards the sun in July, what season will, say for example, Australia have in July? And is it usually summer in Australia in July? What season is it in Australia in July? It's winter in the southern hemisphere. So that statement, the Earth's southern hemisphere is tilted towards the sun in July and away from the sun in January, should be false. Okay, the answer as given is correct. False is the answer. Question number 3.
The hemisphere that is tilted towards the sun has its warmer summer season because it is then receiving 2/3 of the total sunlight that reaches the Earth through.
True. We're happy with the answer being true. Okay, we check. That should be correct. So question number 3 or statement number 3 should supposed to be true. Number 4, Ovio, read out the statement and give us the answer.
The summer hemisphere is also warmer because it receives more direct rays from the sun and the days are longer than in the winter hemisphere. True.
True. We're happy with true as the answer for number 4. Okay, correct. Let's move on to question 5. Or statement 5.
The hemisphere that is tilted away from the sun has its older winter season because it is then receiving only 1/3 of the total sunlight that reaches the Earth. True.
We're happy that the statement is true for number 5. Yes, okay, good. Let's move on. Number 6. Statement 6.
The winter hemisphere is also colder because it receives less direct sunlight from the sun and days are shorter than the summer hemisphere. True.
True. Double check. Everyone, we're happy that the statement is true, number 6. Okay, number 7. Anita, statement 7.
Australia's summer solstice is 22 June and 22nd December is its winter solstice. True.
We all happy that the statement is true? No, there are some people who are saying no here. Marian, that statement again and your answer. If it is not true, then can you read out, Marianne, your statement? Or the statement and the
Australia's
answer?
summer solstice is 22nd June and 22nd December is its winter solstice, false.
False. We already know that June in the southern hemisphere, it is winter. So it cannot be summer solstices for Australia on June the 22nd. Therefore, the answer for statement number 7 is false. Doreen, statement 8.
The longest day occurs at the winter solstice. The shortest day is at the summer solstice. False.
False. We happy with that statement? Answer has been false? Okay, good. Number 9, statement 9.
At Australia's summer solstice, the sun shines directly overhead on the Tropic of Capricorn. True.
We're happy that it's true for statement 9. Yes, definitely, the statement there is true. Statement 10 and the answer to statement 10.
At the time of summer solstice in the northern hemisphere, the sun is directly overhead the Tropic of Cancer. True.
We're happy that it's true. That statement, statement 10. Yes, true is the correct answer. Statement 11, Silo.
At the times of the equinox, the sun shines directly overhead on the equator. True.
We all happy that it's true, that statement? Yes, correct. And finally, let's look at the last statement, Dorothy, and that is statement 12.
An equinox occurs on 22nd June and 22nd December. False.
False. We're happy that it's false. Okay, so the last statement then is false. Do your corrections? And for those who got the answers wrong, you can double check where you have gone wrong, see why or where you have gone wrong, and you make your corrections accordingly. Okay, with that information, that will also conclude our work on part 1, which is on the earth. So if you can make reference now to the booklet that we are using for this particular content work, and the booklet is Grade 11, An Introduction to Climate. If you look at the information from your booklet, we have just completed part 1 on the earth, and today we are going to move on now to part 2, of which the information in our booklet on part 2 has 2 sections, and the 2 sections that we are going to cover or complete on this section part 2 is on the atmosphere, and as well as that the information on solar radiation. So we will start off now with the work on the atmosphere. We look at the introduction, and then from the introduction on the monitor, we will go over to looking at the information presented on the handout or the worksheet which has been distributed. You will also be required to make reference to the information on page 6 of your booklet, of which that information contains work to be covered on the atmosphere. I'll rephrase that, sorry, it's not page 6, I think it is page 5 of your booklet, which contains the work on the atmosphere. You will also notice that in your booklet, there is only 1 page of work on the atmosphere. There is more that we've got to expand on this particular topic on the atmosphere, but we will look at the work on the atmosphere based on the influence it has on generally the climate of the world. So it is mainly the introduction part of the work on the atmosphere that we are actually going to spend time on looking at. Okay, with the introduction now on the atmosphere, from the monitor, it tells us that our planet Earth is surrounded by a layer of air, which we call the atmosphere. The atmosphere consists mainly of the gases of nitrogen, oxygen, argon, and carbon dioxide. Those are the main gases which are found in our atmosphere. The atmosphere also contains a varying but small amount of water vapor and other rare gases. From the handout that we are going to look at or go through, we are going to also see some of the other gases which are not mentioned from the introduction. Note, the Earth's atmosphere, if we are looking at the history now of those different gases found in our atmosphere, the Earth's atmosphere has been changing throughout its history. The advent of photosynthetic life has contributed significantly by greatly increasing the oxygen content in our atmosphere. So if we had to look at a pie graph to generally show us the amount of different gases that are present in our atmosphere and the changes to the amount of those different, the main different gases in our atmosphere, then if we look at 4,500 million years ago, that particular year is very important or significant because it has to do with when the Earth was first formed. Okay, so approximately about 4,500 million years ago, see the component of gases within our atmosphere. CO2, which is carbon dioxide, see the proportion. It's actually about 2/3 present in the atmosphere. Then we have nitrogen, and we also have hydrogen. This is what the content of the gases in the atmosphere would have looked like 4,500 million years ago. If we look at the statement tells us that the amount of gases has actually been changing in the history of the atmosphere or the Earth's formation. So let's look at 3,500 million years ago. We make comparison now with the amount of carbon dioxide with 4,500 million years ago. We make comparison of the amount of nitrogen, and we also make comparison with the amount of hydrogen. So you look at 3,500 million years ago, and we go back to 4,500 million years ago. Are there any differences in the proportion or amount of gases? Yes, definitely. You look at CO2, which is carbon dioxide, and nitrogen, 4,500 million years ago, and you look at those 3,500 million years ago. What has happened to the amount of nitrogen? It has increased. How about the amount of carbon dioxide? There is a decrease, definitely. Okay, we look at another year to make the comparison of changes. Then we're looking at 1,500 million years ago. So with 1,500 million years ago, you look at the amount of nitrogen. Again, it has greatly increased. We have carbon dioxide and also oxygen now included here. Prior to that, no oxygen. About 1,500 million, the changes now, and also the introduction of the other gases. And today, the present day, if we have to look at the amount of gases that we have in the atmosphere, then we still have nitrogen, the biggest proportion. Then we have oxygen. You also have argon, and then there are the others. And the others would include gases like carbon dioxide and etc. So today, when we're making a comparison with the gases in our atmosphere, this would be maybe closer to what the proportion of the different gases would look like. Okay, any queries or questions with regard to that? That's for the introduction of our work on the atmosphere. No? Okay, we'll move on. Looking at our atmosphere and the study of the atmosphere, we can actually come up with different cross-sectional views or diagrams, and those different cross-sectional views or diagrams can show us the different zones within the atmosphere. The atmosphere is actually zoned, similar to when we looked at the structure of the Earth. When we looked at the structure of the Earth, we said the most central part of the structure is the core. As we go away from the core, we come to the next part of the Earth, which is the mantle. And then the outermost structure of the Earth would be the crust. Similarly, we can zone the atmosphere into different zones, starting from above the surface of the Earth. There is a term that we use to describing this particular zone of the atmosphere. Then we move further up, a term we use to describing the next zone, and then we move further up as a term we use to describing the next zone, and etc. So what we are going to do is we look at the different zones of the atmosphere. I'd like to make reference to our booklet before we go on to the readings from the handout. Okay, from the booklet, it tells us that the air in the atmosphere, or the air in the atmospheric system, is actually a mixture of gases which are held around the planet by the force of gravity. The major gases that are in our atmosphere are nitrogen. Approximately 78% of all our gases are nitrogen. And oxygen is the next major gas, and we have about 21%. Then carbon dioxide is also found, but in very small quantities. Those different gases we have looked at already generally when we were looking at the proportion and changes in the history of the formation of the atmosphere. Let's now go over to the handout, and from the handout we have the information presented on the composition of the atmosphere. While we are looking at the composition of the atmosphere, we have looked at some of those gases, and beside nitrogen, oxygen, and carbon dioxide, the other gases you will also find on table 7.1. Okay, you have argon is another of those gases found in our atmosphere. Neon is another of the gases found in the atmosphere. Helium, krypton, hydrogen, and xenox. These are some of the gases which are found within our atmosphere. It also tells us that we have water in the atmosphere, of which the water can also be in the solid, liquid, or gaseous state. Then we also have solid particles, organic and inorganic types, which can be found in our atmosphere. For example, if we're looking at a solid particle, we have soot. You remember in the burning of fossil fuels, usually perhaps if you have a white paper or a white shirt and you place it over the fire, not to burn it, you place it over a fire which perhaps they're burning tire, then what you'll see is a lot of the black stuff collected. They are in solid form. They can be classified as solid particles found within our atmosphere. Soot is an example. Then we also have another gas found within our atmosphere is that of ozone. And in ozone, we have, when we look at the environmental issues, one of the problems which the world is actually having to maybe try to control is the amount of pollutants and the amount of gases which we put into the atmosphere that are contributing to the breaking up of the ozone layer. But generally, those are some of the constituents or gases that we find within our atmosphere. You will be required for your homework to read through the composition of the atmosphere. And then in our next lesson, what we are going to do is we are going to do some comparison of different characteristics of the different layers of the atmosphere. Okay, the next thing that I'd like us to look at is looking at the different zones in terms of a cross-sectional view of the atmosphere. And when we look at our atmosphere can actually be zoned also. One of the common ways in which the atmosphere is actually zoned in line with is to do with the temperature zone or the temperature changes. The diagram you have in your exercise, sorry, not the exercise book, but in your workbook on page 5, which is figure 7, contains a sample of the zoning of the atmosphere according to what we call temperature zones. Therefore, words such as troposphere is used, which is supposed to be the first layer of the atmosphere from the surface as we are going up. After the troposphere comes the next zone, and that next zone is referred to as the stratosphere. We go further up. After we leave the stratosphere, Then we have the next zone, which is known as the ionosphere. These zones here are to do mainly with the changes in temperature. Because then you come across words like mesosphere. You also come across words like maybe the exosphere. All of those words, where do they fit in? They also fit in according to how we use, or the different zones we use for classifying the different layers of the atmosphere. For the words like troposphere, stratosphere, and ionosphere, they are to do with the temperature zoning of the atmosphere. In our next lesson, we are also going to look at the composition zones of the atmosphere. And when we zone the atmosphere in composition, then we will come across words like the homosphere and the heterosphere. Then you're wondering, where do they fit in the layer of the atmosphere? They definitely fit in, but it's just that there are different classifications that we can use in zoning the atmosphere. We also come across words like, say, for example, if we're looking at, if you make reference to your worksheet, and if you make reference to diagram 7.1, you will come across words like the turbosphere, and then you have the diffusosphere. Those are words also used together with the atmosphere, but they are to do with the dynamic zones of the atmosphere. You also have zoning the atmosphere according to the other gases zone. So if you're making reference to figure 7.1, you will see the ozonosphere and also the, the ozonosphere and the ionosphere. But to do mainly with the temperature zones, we have this diagram here to show that, and as well as that figure 7 in your booklet. You will be required then to actually construct a cross-section showing the different zones of the atmosphere into your exercise book. And when you do the construction, you will be required to use the temperature zone terms to describing the different zones of the atmosphere. And the temperature zone terms are what we know as troposphere, the first layer, stratosphere, the second layer, and ionosphere, the third layer. Any queries or questions so far? No queries? No questions? Okay, then we'll move on. Here again is a sample of another example which we can use to showing the temperature zones of the atmosphere on the surface, with a sample of Mount Everest shown here, simply because Mount Everest is the highest point on the Earth's surface, and when we're looking at zoning the atmosphere, we're using altitude. The further up we go, the different zones tend to be distinctive. So we start off with the troposphere, and then we come to the stratosphere, and then we come to the mesosphere first, according to information here, and then we come to the ionosphere. This is another way of showing the same information which you will find on figure 7 in your exercise or textbook. We can also show that information, again, the temperature zones of the atmosphere, by including what we call the changes in the temperatures, giving us those different zones. The black line here indicates the changes in the temperature as we go higher up. So as altitude increases, temperature also changes. That is the reason for why this cross-section is supposed to be showing temperature zones, or the zones of the atmosphere with temperature variation. Okay, so if we have to understand this particular graph to show the same information, we have here temperatures in degrees Celsius. 0 degrees, minus 20 degrees Celsius, minus 40 up to minus 100 degrees. As we go towards the left side, we go from 0 degrees to 20 degrees, 40 degrees Celsius, and etc. On the vertical axis, we are on the left-hand side here, the information is showing pressure in millibars and what happens to pressure as we go higher up into the atmosphere. On the left-hand side, on the right-hand side here, we have the height in kilometers. So we start off from 0, that's on the surface, and we go up to about 100 kilometers. Okay, make reference now to the black line here. This black line here represents the changes in temperature. Generally, within the first layer of the atmosphere, which is the troposphere, how can you describe the changes in temperature by looking at this graph? Noel, how can you describe the changes in temperature by simply looking at this line here within the troposphere? No? Someone like to tell us how you can describe the changes in temperature by looking at this line here, the black line? Mason, what do you think?
The higher you go in altitude, the temperature decreases.
Okay, very good. But we do not want to say that the higher up we go into the atmosphere, temperature decreases. That's not true. Huh? It's only true for the troposphere. Because according to the line here, the higher up we go, temperatures decrease. Is that true also from what we have studied about altitude and temperature? Yes. If you were at sea level, the temperatures are hotter. As you go up towards the higher altitude, temperatures decrease. So from the graph here, you can see that within the troposphere, the first layer of the atmosphere, temperatures tend to decrease the higher up we go. But what happens by the time we reach the end of the troposphere, according to the graph here? The temperature increases, or it is steady. Sorry, it doesn't increase, it is steady for some kilometers, and then once we come to the stratosphere, what is now happening to the temperature? It tends to increase, because when we are going this way, temperature is increasing. When we from 0 and we are coming this way, temperature is decreasing. So in the troposphere, the higher up we go in the troposphere, temperatures decrease. Once we reach the end of the troposphere, temperature is steady for a couple of kilometers, and then in the stratosphere, the temperatures start to increase. Can you see that? That is what this line is showing. We reach the end of the stratosphere, and the zone that shows that is the stratopause, which is the end of the stratosphere. Then temperature is again steady for a certain kilometers, and then the temperatures in the next layer, which is the mesosphere, starts to decrease as height increases. By the time we reach the end of this particular zone here, the mesosphere, we come to the mesopause, which is the end of the mesosphere. Then temperature is steady again. Then it starts to increase when we come to the thermosphere. So here you're looking at the changes in temperature. So do not think that the further up we go into the next zone and to the next zone, the temperatures will still decrease. No, that's not true. This graph then shows what happens to temperature. Therefore, when we are zoning the temperatures, when we are zoning the different layers of the atmosphere, there are many different terms that we can use, but for what we have in our workbook, it is mainly to do with zoning of the atmosphere according to changes in temperature. Okay, so that diagram shows that information. What I would want you to work on now is you have the background readings to look at from the handout that was distributed. And what I would like you to do is, into your exercise book, I would like you to construct an example showing a cross-section of the different layers of the atmosphere from the surface to the furthest limit. And when you are actually putting in or constructing your diagram, it is important that you use the different altitudes correctly, because the altitude, the higher up we go also, can give us a boundary separating one zone from the next. And the 3 zones, or actually the 4 zones that we have looked at so far today, are the troposphere, the stratosphere, the mesosphere, and the ionosphere. And your task now is to do a construction showing those different layers of the atmosphere. I'm going to put the information back onto the diagram so that you can use those diagrams to actually help you with your construction. Otherwise, you can refer to page 5 of your booklet, figure 7, to help you with the construction of the different layers of the atmosphere. Okay, have you made note of the activity? Yes? Okay, we can select. You can select from the booklet, figure 7, or you could select from the monitor here for the construction of your cross-section. I'll give you at least 5 to 6 minutes to work on the cross-section. Put it into your exercise book. You have a choice, like I mentioned. You can make reference to figure 7 to make note of this, or you could use what's there. You see this particular chart here shows you nicely the different ways of
Dynamic zones.
Here we're looking at the zones whereby changes occur quicker, and then the zones that you have where changes within the atmosphere varies or changes. So if you have to look up the meaning to what diffusion is and turbo, like in the movie Knight Rider, maybe if you watch, you put on turbo boost, and what happens? You go very fast. Yeah. So here within this zone here, all the way to this point, perhaps the changes are fast. Whereas when you come to this here diffusion, that means there's a lot of maybe different little changes that occur. If you know what the meaning of diffuse is, yeah. And in most of the times, maybe from grade 7 up to 10, we learn mainly about the temperature zones. That's why we know the troposphere, we know the stratosphere, we know the ionosphere. But then if the words like, someone might ask you, homosphere, and you're wondering, where does that come in? That's because it's another way of classifying the different zones of the atmosphere. It's to do with the composition zone, this one, and then that one. This is to do with the dynamic zone. And these are the other gases like, where a lot of ozone is from above the cloud level to that point, and then the ionosphere. It's to do with a lot of where the ion particles. That's why it's called ionosphere. But you have to read the handout here to really understand that information. It's all here. You can make reference to the, this is the same diagram, just in case that. You can make reference to this. It's the same one. Okay, listen, we have about 2 minutes to the end of our lesson. What I'd like us to do is I'd like us to conclude the work we're doing today, and for your homework, I'd like you to ensure that you have a construction done on the cross-sectional view of the different layers of the atmosphere done into your exercise book. Okay, to maybe summarize what we have done so far, let's look at what we have covered. Gao, would you like to tell us the main gases which are found within the atmosphere, or what are the main gases that are found in the atmosphere?
They oxygen, nitrogen, and carbon dioxide.
Okay, oxygen, nitrogen, and carbon dioxide. Are they the only gases that are found within our atmosphere? No, but they are the main gases found within the atmosphere. There are also the other gases, but in small quantities, which are also found, and you will find that information from the readings. I think it's figure 7.1, the table that contains the other gases. We've looked at the zoning of the atmosphere. Similarly to the structure of the Earth, the atmosphere can be zoned according to the changes in temperature or temperature zones. Caleb, could you give us the different temperature zones in our atmosphere from the surface right to the maybe 100 kilometers above?
Troposphere, stratosphere, mesosphere, and ionosphere.
Okay, very good. We're looking at the troposphere, followed by the stratosphere, followed by the mesosphere and the ionosphere. What we are going to do then is I will want you to collect any information that you have or that you can find about the atmosphere. And in our next lesson, we are going to look at characteristics of the different layers of the atmosphere so that we are familiar with what are the main maybe features that are found in those different zones or layers of the atmosphere. And that's what I'd like you to do for your homework. You bring those information with you to class in our next lesson so that we can use that information for the completion of a table that we are going to do, and the table will contain some of the main features or characteristics to recognize those different zones of the atmosphere we have looked at. Class, that will also bring us to the end of our lesson. If you can stand up now, please. To the pilot teachers, our keyword for lesson 90 is stratosphere. Good afternoon, and thank you, students.